Evaluate the limit with closed forms. The closed form is an expression or a formula only. This function has only one formula, one closed form. For part A, at x go to 1, the term x go to 1. The term x go to 1. And so what we have is 1 minus 2 over 1 plus 1, which is negative 1 over 2, which is the answer. For part B, the term x would go to 4, and the x inside the radical would go to 4. Now this is why we need to rewrite the limit notation here. With this limit telling us that x goes to 4, we wouldn't be able to do this. At x goes to 4, we write this as 4 plus the square root of 4, and so this is 4 plus 2 or 6 as the limit. The reason why in both of these cases we can just simply plug in a to the function to determine the limit of the function is because each of the function is continuous on its domain and a is in the domain. For part A, the domain of the function is a set of all real numbers such that x is not equal to negative 1. If x is negative 1, then the denominator is 0. And so this function is continuous everywhere except at x equals negative 1. But we're looking for the limit at x goes to 1, where 1 is in the domain of the function. That is why we're allowed to just simply plug in and evaluate the limit, because the function is continuous on its domain and 1 is in its domain. For part B, the function is defined on all real numbered x, that is 0 or positive. We cannot use negative x because we cannot take the square root of a negative number. And so this function is continuous from 0 to positive infinity. 4 is in the domain. And so, since the function is continuous on its domain, we can just simply plug in 4 to evaluate the limit.